In this video I'm going to explain what we mean by the term highest common factor and explain and demonstrate how to calculate the highest common factor of two numbers. In order to do that, there are some things you must be able to cope with already, all of which, fortunately, I've already done videos on, so you might need to go back and have a look at the videos on what are factors, what are prime numbers, and how to calculate the prime factors of a number. All of those are available here on the website there, links in the description down there, as the YouTubers all say. So, highest common factor means the largest number which will fit into both of, or possibly more than two, the other numbers that you're looking at. So you'll be given probably two numbers and asked to find the highest common factor, which is the largest number that will fit exactly into both of them. And in order to do that, the first thing we do is calculate the prime factors of the number. Then there's a little elegant sort of thing we do with the prime factors, which I hope you'll be able to understand, because understanding is paramount. And it all drops out and it's all quite straightforward. So, firstly, as an example, I'm going to use the numbers 180 and 1386. And I need to be able to list all the prime factors of each of those numbers. So I'm just going to work out the prime factors of each of those numbers over here. Then we can put them over there. So 180. 2, yes, 90. 2 go into that, yes, 45. Does 2 go into that? No, but 3 does, and that's 15. And 2, no, 3, yes, 3 times 5. 5 there. Okay, so for this one, I've got 2 times 2 times 3 times 3 times 5. So I'll write those here. So those are the prime factors of 180. So to do the prime factors of 1386, firstly, does 2 go into that? It does. 693. Does 2 go into 693? No, it doesn't. 3, however, does. 231. Does 3 goes into 231. It must do 77. What goes into 77? 711s, isn't it? 711, those are prime numbers. 7, 11. Okay, 2 times 3 times 3 times 7 times 11. Okay, so we've got the prime factors of that and this. 2, 2, 3, 3, 5, 2, 3, 3, 7, 11. Now, to find the largest number that fits into this one and into that one, I need to find the largest number that I can make with both this set and that set of prime factors. So what effectively I've just got to do is identify the numbers that appear in both of them. So, firstly, I can see that I've got a 2 in both of them, so I can use that. So I can put 2. And there's another 2 here, but not over there, so I can't use that one. There's a 3 here, and there's a 3 there. So the 3 appears in both, so I can use the 3. My next number is 3. There's also another 3 over here, so we can use that one. The 5, of course, doesn't appear in this one, and nor do the 7 or 11 appear in that one. So the numbers that appear in both of them that we can use are 2 times 3 times 3. So 2 times 3 times 3 is going to be a factor of that, and it's also going to be a factor of that. And there's nothing else we can do. So we do that. 2 times 3 is 6 times 3 is 18. So 18 should be a factor of that. Well, it clearly is, because it's 10 18s. This one here, if we divide by 18, we will find it does work. It will be, well, if we divide that by 18, we get 7 11, we get 77. So 77 18s make up that number. There we go. So that's our answer. It really is as simple as that, isn't it? That wasn't very difficult, and I'm hoping, very, very much hoping, that you can understand what's going on. To help you understand what's going on, I'm not just going to stop there, much as you'd like me to, but you can always press the stop button. I'm going to do a couple more so that you get a bit more of a feel for it. So bear with me while I rub that one off, and then we'll have a go at another one. I bet you never thought I could move so fast. Okay, next one, we're going to try 1,210 and 330. Right, so 1,210, 330. So firstly, I'm going to run through finding the prime factors of 1,210. Okay. 2's into 1,210 are going to be 605. Okay, 2 doesn't go into 605. 3 doesn't go into 605. I know that because I add the digits together. It doesn't add up to a number that's divisible by 3. 5's obviously goes into 605. That's my next prime number. So 5 into 600 is 120. So that's going to be 121. What goes into 121? That's interesting. 121, that's 11 11s, isn't it? So my prime factors 1,210 are 2 times 5 times 11 times 11. So I'll put those over here. Right. Now let's do the prime factors of 330. 2 clearly goes into that. 2 goes into 330, 165 times. 2 doesn't go into that. 3 goes into that. 3 goes into that 55 times. 55 is divisible by 5, but not any of the other lower ones. It's 5 11s, isn't it? 11 is a prime number, so we have to stop there. And we get 2 times 3 times 5 times 11. Okay, so I've got my prime factors. Now I have to see which prime numbers are common to both of those. So I'll start with the 2. Yes, I can use that one. So 2. What else have I got? I've got a 5 in there. And there's a 5 here, so I can use the 5. Let's put a circle around that. And I've got an 11. And yes, there's an 11 over here. That's fortunate. So there is times 11. There's another 11 here, which isn't in that one. And there's a 3 in here, which isn't in that one. So those are not common. So the biggest number that I can actually make from that one and from that one is 2 times 5 times 11, which is 10 times 11, which is 110. So clearly 110 fits into both of those numbers. Okay, I think we've got time for another one, so I'll do another. Okay, how about 1,911 and 1,092? 1,911, 1,092. Right, so let's first of all do the prime factors of 1,911. 2 doesn't go into it. 3 does. That is 3 637s, I think. 2 doesn't go into that. 3 doesn't go into that. 5 doesn't go into that. 7, 91 times. 7 goes into there 91 times. What goes into 91? 2 doesn't, 3 doesn't, 5 doesn't, 7 13 times. So 7 13 times. 13 is a prime number, so we've just got 13 here. So this one, 3 times 7 times 7 times 13. (1092). Sorry, I seem to spend most of this video with my back to you. I apologise for that. 1092. That is divisible by 2. So 2 into there gives me 546. 2 also goes into that one, which is 273. 3 goes into 273, and it goes in, I believe, 3 9 27, that's 91 times. Go back to 91 again. And we said that 7 goes into 91 13 times. So 2 times 2 times 3 times 7 times 13. So this one, 2 times 2 times 3 times 7 times 13. Okay, so we've got our sets of prime factors of both of these. And we go through these, finding out which numbers appear in both of them. Doesn't matter which one you do first, by the way, as again, you'll get the same answer. 3, there's a 3 there, there's a 3 here. So I can use the 3. There's a 7, and a 7 over there. So I can use that 7 and that 7. Another 7 here. Do we have another 7 on this side? No, we don't. There's a 13. We do have a 13. Okay, so we've got times 13. Okay, we've got to work out 3 times 7 times 13. 3 times 7 is 21. That'd be 273. Wow. I hope so. Okay, so we should find that 273 is a factor of both of those things. You may occasionally get two numbers where there are no factors. You may occasionally get completely different sets of prime numbers for both of these, in which case there are no common factors, so you can't give a highest common factor. Well, I suppose you could say 1. So that concludes that one. I will rub all this off and put a few examples up there for you to try in a moment. And there's also going to be a video on lowest common multiple, because that's another similar technique. Okay, I've rubbed off all the other stuff. I put up some questions. I've decided to put them on that side. And in the worked examples video down here, I'm going to be going through those and showing you how to do them all. I really will be whizzing through the prime factor calculations that are like that as I'm on helium, just to get through that part, because that's not the crucial bit. Please pause this video before the end, write those down and have a go at them, and then see if you can do them and watch me go through them just to confirm that you can. And hopefully all will be well. So I should hopefully see you in the next video in a few minutes.